So hi everyone. So today I will show you how to set up for client and server. So first of all, before we start, we need to make sure server we need to set up our networking, which is adapter 1. We need to make sure which is NAT for adapter 2. We need to set up for internet networking. And then after we set up for the server, we will set up for the client. Also in the networking side, which is we need to make sure our networking for a client only internal networking for adapter 1 and internal networking for adapter 2. After that, we open our terminal in server. So we write this command and then insert our password. After we insert password, we open to the plain text, which is our file, and make sure we write our address and net mask for our server. After that, we save it in our file and go back to our terminal. After that, we write this command to connect with our client. Somehow it will be error, so we come back with and then write this command back to make sure the server can connect with the client. And after that, we can continue with our DHCP, SFTF, also network web server and database. That's all. Hi, my name is Amira Sabinti Alafiza, and my metro number is B1525100858. So today, I'm going to setting up a DHCP server on Linux using the ISC DHCP server package. This server will automatically assign to IP address in any client machine connect to our network within the range of 192.168.1.5 to 192.168.1.10. So, point 10. So, first, let's update our package repository list and install the server software. I will open my server terminal and run this command. So after I write this command, I will wait for the installing process to complete in my screen. Alright, okay, next we need to tell the DHCP server which network card or interface to listen on for incoming client requests. So let's open the environment default file using nano. So we need to run this command, which is sudo nano etc default ISC DHCP server, and then after that we need to scroll until we find interface v4, and from that to the EMP0XN. So we need to open the DHCP configuration file. So we write in our terminal, which is sudo nano etc DHCP all the way from to the bottom of file, and then we need to make sure our subnet, our range, and all the text we need to rewrite in our file. And then we need to start the service, which is in our server. We need to write this command. After that, our server configuration is complete and running. Now let's switch over to the client side to test it out. Let's run a quick ping test to ensure stable network communication between our machine and the DHCP server gateway at 192.168.1.258. So we need to write in our terminal after we write this command, client reply with the zero packet loss, which is both the service setup and the client integration are working perfectly. So that's all from me. Thank you.
Assalamualaikum and good day to doctor who are watching this. I am Nur Batrisha Carmila from Baxi S1G1. I am from the group Red Hat and I am in charge of SFTP server configuration. First and foremost, SFTP is Secure File Transfer Protocol, which allows users to safely upload or download files. So first step is we have to create a dedicated group and a user for SFTP access using the following commands. Next, step 2 is to create a dedicated directory for file uploads and set secure permissions using the commands here. And step 3, we have to restrict this user strictly to SFTP to prevent full shell access. And we have to open the SSH daemon configuration file using this command. And we have to append the following lines to the very bottom of the file before this. So the lines is here. Then we have to restart the SSH service to apply the changes by using the restart command. After setting the SFTP on the server side, now we have to test on the client side. We have to run this command on the terminal and enter the password. Then we try run CD uploads and transferring file to ensure the permission works seamlessly. That's all for SFTP part. Thank you.
Hello and Assalamualaikum. My name is Khairil Amirin from Red Hat Group S1G1. Today I will present about my task in the Internet Web Server. I utilize Apache to ensure that employees on our isolated private network could safely access company resources. First thing first, I start by installing the web server package using this command. And then I will open my configuration file using this command. After I open the configuration file, Apache servers file from the /var/www/html/directory by default. Instead of relying on the standard welcome screen, I open the index.html file and wrote a custom HTML script tailored for our company, featuring a welcome header and a confirmation message. So after that, we need to check the status after saving the file, and I ran a sudo systemctl restart apache 2 to ensure the system will run perfectly after entering the configuration file. I switched to Linux client virtual machine and simply switch to the website. To prove the website server is reachable across our private virtual network, I will navigate to the server static IP address and as you can see here, the page successfully loads our custom HTML file, confirming the Apache web server is fully operational and securely isolated to our internet network. That's all from me. Thank you.
Assalamualaikum and hi. My name is Ali bin Bukhari. Matric number B1525-10130. I am from Baksi S1G1. Today, I will be presenting the individual demonstration for the database service segment of our group project. I am from the Red Hat group. First, let's verify the operational integrity of the database service. I will use the sudo systemctl status MariaDB command to ensure continuous uptime and that the database initialize automatically upon system boot. The service daemon was enabled and start. As you can see here on my screen, running systemctl status MariaDB confirms that the database engine is active and running smoothly without any error. For the second step, I will authenticate into the database management system. During the setup phase, the environment was hard using the command script, removing anonymous users and disabling remote root login. I will now log in securely using local Unix socket and the dedicated administrative root password. Now that we are inside the database console, I will switch to our isolate project workspace database using use BaksoDB to validate data retrieval and schema integrity. I will run a standard SQL selection query on our company assets table, which structure our network infrastructure inventory login. As demonstrated by the output grid, the record including our central server and client node IP address are successfully fetched. This confirms complete data persistence, correct field indexing and flawless back-end rendering. Now we have arrived at the end of the part. We use the exit command to log out from the database section. With the service active, access securely authenticate and data queries successfully validate. The database infrastructure is fully operational and ready for the enterprise network. Thank you for your time.
I would like to ask you some question about your individual part, which is DHCP. What happens to the client if the DHCP server stops working?
So if DHCP stop working, the client will not get a valid IP address from our network. Instead, it will fall back to a user's automatic IP. This completely break communication, meaning the client will be able to open website or connect to the database.
Next, where and how do we limit the IP addresses given out to clients?
We define it in the DHCP configuration file using the range command. For our project, we limit this range to IPs between 119.168.1.5 and 192.168.1.10. So today we'll ask you about SFTP. So my first question is, why did we use internal SFTP instead of the standard SFTP serve?
This is because we are using a crude jail to log users in their folders. The standard SFTP server needs external system files and a shell to work inside the jail, whereas internal SFTP is built directly into SSH and works instantly without needing extra files.
Oh, okay. For the next question, what is the strict rule for crude directory permission?
The crude directory, like var/SFTP, must be owned by root and cannot be writable by regular users. Permissions must be 755. If a regular user is given write access, OpenSSH will automatically reject the connection before they can even log in. Why can the server download files from the internet but the client is completely blocked?
Alright, thank you for the question. It depends on our VirtualBox settings. The server has two network cards. One set to NAT, which is give internet, and one set to internal network. The client only has one card set to internal network, keeping it entirely isolated from the outside of the world.
Next, how does the client open the website hosted on the server?
The client types the server's private IP address. For example, http://192.168.1.254 into its website browser. The request travels through the VirtualBox, which is internal network that connects both VMS together.
So for the first question, why can't the client connect to the database using the local host?
Okay, thank you for the question. For me, localhost means this machine only. Since our database is on the server VM and our client is on a separate client VM, the client must use the server actual network IP address to connect over the network.
Okay, so the next question is, why did we use the percentage wildcard in the database grant command?
Okay, the percentage acts as a wildcard since our DHCP server changed the client IP dynamically within the 192.168.1.x range. The wildcard tells the MariaDB to permit remote access to any machine coming from our trusted private subnet.